Hello and welcome, everyone. Thank you so much for joining this episode of the Tyk webinars. Today, we're going to be talking about the OWASP Top 10, staying ahead of security threats to your API-first business. Hello, I'm Budha, Product Evangelist here at Tyk, and I'm joined here today by two incredible guests. First, we've got Stefania. Hello and welcome. Thank you so much for joining us.
Thank you, Budha. Hi, everyone. I am Stefania Chaplin, aka DevStefOps. So I am a solutions architect at Gitlab. I've been in application security, I've been in and cloud security as well, but I've been in security for a long time. But before that, I used to be a developer. So I've seen both sides of it. And I used to spend a lot of time in REST APIs. So I'm one of those cool people that when you present a JSON to, I know exactly which Python command I need with all the squiggly and brackets to get to the exact key value pair you want. So yeah, having been a developer in security, this is definitely, as I said, a very important topic to me.
Fantastic. We're really, really glad to have you. There's a lot to talk about today, so definitely looking forward to that conversation. On to you, David. So tell us a little bit about yourself before we get started.
So I'm technical director at Tyk, and I'm working in the research team. But my background is also, like Stefania, as a developer in the technology space for over 20 years now, actually, so long time. But in more recent years, I've been doing more sort of client-facing things, and now more research. So looking into the market and product direction and technologies and that sort of thing. And that's how I've become more familiar with OWASP as well.
That is incredible. In fact, you've actually written a series of blog posts, which is all about this OWASP Top 10 API security threats, which when you do get a time, I think we will share the link with you after this session. So do feel free to have a read. So without further ado, let's kick things off for today. We're talking about API security. And of course, if you have worked in the world of digital technology in any capacity, you would have heard that security is a concern. A few years ago, the conversation was really about whether we need APIs or whether we want to be API first at all, or what that essentially entails. But I think in the recent past, the conversation has really shifted away from whether we need APIs to we definitely need APIs. That is a given. But with the ubiquity of APIs, how do we make things better? While APIs have been ubiquitous in this modern digital landscape, API security, however, has taken a bit of a backseat, surprisingly. So according to a research that was done earlier this year, I believe, where we saw 681% as the number, the increase in the API attacks in the past 12 months. That is quite the leap. And just to look at the number on the right-hand side completely to go with it is essentially around 34% of the people who were interviewed for this process, they said that they did not have a robust or any kind of API strategy that is put in place. So you would think that is a bit surprising. You would think that that is something that needs to be addressed. And with that in mind, we wanted to go into the people who are the known entity in the world of API security. If you think API security, OWASP comes in every single time. They have their top 10 security threats that they address almost, I think, on an annual basis. This time specifically, we are looking at API security and not just security threats in general. So OWASP, for those who are unfamiliar, OWASP stands for Open Web Application Security Project. That's the full form. And basically, they are a foundation that provides tools and resources that helps developers or builders or creators of applications to understand and mitigate against threats posed to internet applications, specifically or including API. So today we are going to be looking specifically at API. So that in general is what OWASP is all about. And that's kind of what we're going to be focusing on today, the API securities, the importance of addressing them, what they stand for, why they are relevant, some stories from the wild, and just getting to know a little bit about these top 10 security threats, how you can address them, how you can manage them better so that you run a successful business and one security failure does not take it down in its entirety. So with that, my first question for today goes to David. So David, tell us a little bit about these top 10 API security threats.
Sure, okay.
I've got a helpful slide to help you out with it, so go on.
Yeah, I'll go through each one. Okay, so first up, and this is in order, so starting with the highest threat first. So the first one is Broken Object Level Authorisation. And this is basically the idea that you're allowing access to data through your API, which users should not have access to. So, for example, let's say if it was some sort of Facebook URL and you wanted to view someone's profile, then if you knew their ID, you would be able to type that in and receive the profile data without actually being authorized to get that data. So Facebook should be checking that you're able to access and you're authorized to access that data. So that's number one. Number two is broken user authentication. This is really just a general bad authentication topic. So this could cover many things, from having weak password policies, which allow users to use known passwords like password as part of their credentials, or it could be things like the credentials are exposed in the URL via a query string, or just that the backend API isn't validating the tokens correctly. Maybe it's allowing expired tokens or doing something else that's not properly validating them. So it covers a whole bunch of topics. Number three is excessive data exposure. This is where data is being leaked from the API. So the request is genuine and fine, but the server is responding with data which could actually be used by a malicious user to actually attack the API. So maybe it's revealing things like API keys within the response or some other sort of sensitive information, or it could be personal data or other confidential data which could be used to attack somebody or some organization as well. Number four is lack of resources and rate limiting. And this is probably quite a well-known topic to anyone who works on the web and has to deal with any sort of load. But this refers to both malicious attacks, such as denial of service attacks, and also just genuine spikes and things like that, where the infrastructure can't deal with it and can't scale. So this typically results in the API becoming unavailable. Number five is broken function level authorization. This is just like number one, but the difference is with number one, which was about the actual data which you were requesting. This one is less granular. It's actually more about the function. So function level authorization. So you could think about it like enabling a standard user to access administrative endpoints, or perhaps you're allowing a user to access particular HTTP methods like delete when they should only be able to do gets. So it's more functional rather than about the data, but it's the same sort of thing as one. Number six is mass assignment. So this one is about, really it's the opposite direction. So this is about allowing data to come in to the API and affect things that it shouldn't be able to do. So it might be enabling a user to change flags on their profile or security data to elevate their privileges or something along those lines. I actually think this one could be called something like broken field level authorization, and then it would fit in with the other two as well. But yeah, so it's about data manipulation from the client. Number seven is security misconfiguration. This one is something that could affect any sort of web app, I suppose. It's commonly, common examples for it are things like leaking information about perhaps the applications or the versions of the applications that are running behind the scenes. So you might reveal that your web server is this certain web server of this version, and that would allow malicious users to then go and find exploits for it. But it can cover a wide range of other things as well, but that's just one example. And number eight is injection. So executing arbitrary code. We've seen this in databases in the past, and now it's spread to APIs as well, because quite often databases are behind APIs. So if you can somehow inject your commands into API requests, then you can do the same things as you could if you had direct access to commands in the API in the database. But it can also be used to run, say, arbitrary commands on the operating system, maybe deleting files or things like that. It all depends on what's really what the tech stack is and what's behind the scenes there. Number 9 is improper assets management. So this is when businesses don't really look after their APIs. So they might have a whole suite of APIs, but maybe they don't really know about some of them. Maybe the people who maintain them have left, and those APIs might go into disrepair. They might not receive the updates they need to patch them when vulnerabilities are found, and then they become a liability. So businesses are either not aware of their existence, or they just don't maintain them. But yeah, that's what that one's all about. Number 10 is insufficient logging and monitoring. This one's about visibility. So if you don't actually know you're being attacked, then there's not much a chance that you're going to be able to do anything about it. So this one is about having the necessary monitoring and logging in place so that, first of all, you can understand you are being attacked, but also importantly, is that you're able to, after the event has finished, look at what happened and understand how the attack occurred and how you can protect against it in the future. So yeah, it's just a lack of logging and monitoring which causes that. So that's the 10.
Thank you so much. All right. That's actually done in a very, very short period of time and done very well, done precisely, because I know having gone into the details of each one of them, there is a lot of details that goes into each one of them, the different scenarios. But an interesting point that I've noticed while you were describing a lot of this is that there are essentially 2 components to this. And I think that's probably true for API security in general, where you've got the technical component of it, where you obviously need to, configure things appropriately and all of that. But there is that human component of this as well, where, things like security misconfiguration isn't really an attacker being extremely smart. It's you being lax on your side in doing the things that you were supposed to, but you haven't. So, it feels like there is that sort of combination of not just technology. Yes, there might be options and opportunities and things that you can enable through the technology, but you need to be aware and you need to make that effort as a human component of it to actually ensure that things are being happening. So question to you on this, Stefania, in terms of of course, starting off with the why behind all of this, why is this relevant? Why is this important? But also, looking at that human problem with a lot of these security threats that we see today, how much of that is actually technology evolving? How much is that is attackers being smarter, or is it just us being lax in our, making sure things are going well?
Okay, a couple of questions, and I was just going to add a comment to David. I really like your renaming of mass assignment as broken field level authorization. I know a lot of people at OWASP, so I'm going to suggest that with the OWASP, they update every few years, and I think that's a much better name. So nice.
There's one due actually, isn't there? Next month there's meant to be publishing a new one, or I know they're working on it. So if I see it, then I know what happened. Thanks.
Exactly. So starting off, why is this important? So a few things. Why is security important? Hopefully, I'm not going to talk too much about this because with security, I'm vegan, and I talk about it like having to eat your fruits and vegetables. So you have to do it if you want to stay healthy. It is something that you need to do. And I always say with security, try and make it fun, try and make it automated, make the right path the easiest path, the frictionless path. So make the path you want to go is the smooth one. Specifically with OWASP, so if like me and you're one of the cool kids that actually looks into the OWASP methodology, they're very scientific with how they come up with the top 10, and they also list it sequentially. So the top one, BOLA, which was the object level authorization, so the Facebook example, I think of it in terms of banking. I go on online banking and I'm looking at my details. I want to look at someone else's. Let me just change the ID number and the URL. Boom. So that's obviously the number one, but I think some of it comes back to this fruit and vegetables. For example, insufficient logging and monitoring. So if we look, which is the number 10, I was reading about a Japanese bank. I can't remember, or someone in the Japanese finance industry a few years ago, and they did not realize they had been hacked until they only realized when enough customers complained, and then they realized that 500,000 had gone from 90 customers, which is the worst. You do not want to know you're being hacked by your customers telling you. You need to have that logging and monitoring in place. So as technology and as API involved, so Gartner a few years ago, they had a stat. So by 2021, so obviously by last year, they said exposed APIs will form a larger surface area for attacks than the UI in 90% of web-enabled applications. So that's with APIs, because a lot of the time you can't see them. Like, I'm a backend developer. I love Python because I'm not visual. Please don't give me any JavaScript or design. But you know, when you have all these microservices, which is the way that you're going, a lot of organizations are going, these APIs connect them. So the attack vector grows, and then what can you do except for having your process, having your principles and policies, having your fruits and vegetables. Another comparison I've had is security are like your seatbelt. We don't want you to, we're not your brakes. We don't want to stop the car, but we do want to keep you safe. So please drive as fast as possible, but please wear a seatbelt just in case. So in response to the human action, I think something that's really important with the human action, because say in the past, you would have physical servers, and it's like, oh, we've had an earthquake or a tsunami, other servers dry. Whilst I think when it comes to APIs and processes, because they're not visible, they're not always documented. So you don't know who can do what and how, and in terms of these processes, what access they have. I've seen some fun stuff, for example, API call that's happening within Docker, someone man in the middles, and then they're in the Docker container, and because that Docker had root, they leave the Docker container within root, and all of a sudden they can then do path traversal and get to the password file. So hackers are clever, and normally it's not just one of those 10, it's normally one of those will link to another one, links to another, and all of a sudden you're in bad news. So I don't think it's necessarily that. I think computers are getting smarter. We're relying more on computers, but we're not thinking the security is coming as an after step. So it's something we just need to think about, and how we can, you know, make security fun, automated, and make it the best, the easiest path possible.
Absolutely. I think there are already a couple of points that I think between the two of you, have already mentioned a couple of points from a security strategy perspective. Don't have password as your password. I think that's probably step one, but you would be surprised how many people still do it, or even variations of password. I think that's also not something that you should do. So definitely one of those things. Secondly, it seems like you should really look at documenting things, document your processes, document your APIs, because one of the key things there is, like Dave mentioned, if someone is leaving an organization and, you know, there are, even if there is no flaw today, but they've been built using specific technology that might be evolving, that might need updates, it might need upgrades over a period of time. It may not be insecure back then, but it may have become insecure in the future. You may or may not realize that if things have not been documented appropriately. So always document. And I know there is an argument with certain technologies where, you know, oh, these are self-documenting APIs, like GraphQL is always touted to be that. I mean, sure, yeah, it is to a certain degree, but that is never enough. That is not going to be enough. You need to really invest some time, get that documentation right, get it to the point which actually helps your users, as well as helps yourself, your future self, even if it's not your present self, but definitely helps your future self. So definitely two key takeaways. And the third one, I think, which I'm going to use as a quote, is make the right path the easiest path. I think that is probably the go-to for API security, because a lot of times people, beyond just not being aware of things, they feel like there is a lot of investment that needs to go into this to actually make things viable. And because of that, and in a lot of cases, people also end up thinking about this from a more binary perspective, where, you know, you're either secure or you're not secure. You're not doing small steps, you're doing big steps. So it's kind of just that mindset of not doing it right towards the end and making things as easy as possible, and, you know, approaching it in that fashion more holistically. So that's 3 key takeaways already in the first 20 minutes, which is fantastic. Dave, I feel like you've got something to add there. Yeah, go ahead.
Yeah, I was just going to say, well, why I think they're important, and this is really just echoing really what Stefania was saying, but APIs do present a wide area for attack, and increasingly organizations are building new APIs. There's new technologies coming on that may not be fully mature yet. And what organizations should realize is that there's really significant risks involved with operating an API, from like losing data to financial penalties through losing that data, and then the reputational damage that will follow. So it's really quite significant. And I think if businesses really understood those risks, then they would really take these threats seriously. And I think the last thing would be that it's not always malicious users who can cause the problems, especially in terms of the rate limiting one. It can just be spikes in traffic, which can cause resources to be overwhelmed and so on. So it's not always a hacker who's trying to break in. It can just be that you've not adequately planned or have enough analytics about what your load is that leads to these problems. So yeah, I think they are very important, and yeah, should be taking more interest in them.
Perfect. So with that in mind, perhaps we start thinking about, okay, organizations may already have a security policy in place, or they might have a strategy in place, but maybe they don't. As we saw previously, about 30% of folks do not have an API strategy. So if we were to take these OWASP top 10 threats as our sort of North Star to think about, okay, these are the big ones, so how do we start addressing them? So maybe let's get your initial thoughts on, how organizations can start addressing them. Maybe Stefania, you could go first on this one. Addressing some of these, approaching the API security strategy based on some of the stuff that we've discussed so far.
Sure. So I think for me, it really depends who you are. So who's listening to the answer to this question. For example, if you are the developer who is creating the APIs, back to your original point, documentation, and just making sure, versioning your APIs, because at some point you might want to go to a next version. If you have a version 1 or a 0.1, lurking around, that could be prone to vulnerability. So if you are, at the ground level, making sure that I call it having a secure mindset. So thinking securely, it's basic threat modeling, thinking about assets, protections, and threats. So, oh yeah, I'm doing data. Do we have what are protections? Do we have an API gateway? Do we have a firewall? And say if you're starting from square one, maybe you're at a startup, or maybe you're in a very small team, and you might be the developer / CTO who's doing this, and there really is nothing in place. That's when I would recommend going for things, for example, like an API gateway, or having some API management, because a lot of the time that has security functionality within it. And then similar, so if you move over to the security architect, then it would be a case you're like, okay, so we're going to put some tooling to, a barrier to help protect us. Just go through the top 10 and think, okay, have we kind of, basic covered? And then, if necessary, go out, speak to a security consultancy, speak to your audit department, be like, have we covered the basics? And that's the other thing I forgot to mention with the OWASP top 10. They come in different flavors, API, mobile, web, but especially if you're in a regulated industry, regulations and legal compliance, a lot of the time they mention specifically the OWASP top 10. So if you have those, I'm not going to promise you're 100% safe, but that would be that'll be a good place to, at least you can hopefully sleep at night for now.
Perfect. Yeah, absolutely. I think that's kind of where you get started, because a lot of times you think about API security and then you're thinking about, okay, there could be so many different threats, and do I get started with all of them, or where do I begin? And a lot of times I think this OWASP top 10 might be able to give you a bit of a direction. Even if you don't go all 10, maybe you get started with the top 3 out of those top 10. And I think that could be a really, really good starting point perhaps. And then you build on top of that. A question to you, Dave. I think an important thing to perhaps note to understand here is that security doesn't work in isolation. I believe when you're thinking about security, it's not one component that is going to be the silver bullet ever. You're kind of looking at API security as a stack in its entirety. So, there are different levels at which you might be addressing them. So could you tell us a little bit more about that element of, thinking about security more holistically for your entire tech stack as opposed to a single component?
Right. Yeah. If we think about the request response sort of chain, it can start even outside of your infrastructure. So it can start at the very edge at sort of CDN level. It can start with providers like Cloudflare, who can perform monitoring and defense against things like denial of service. And then when it's hitting the API, before the API, it can hit an intermediary like an API gateway. Coming from an API management company, I should mention. But yeah, so you can put things in place in front of your APIs that provide a lot of boilerplate security. So, you know, API gateways, they can implement things like OpenID Connect. They can do things like rate limiting. They can put all sorts of access control policies in place before it even reaches your API itself. But when it does reach your API server, that's really the last line of defense in a way. And that's where you need to be doing things like dealing with BOLA, actually, the number one, because it's only in the API server that you have the necessary information to make judgment on whether the request is asking for data that it should or shouldn't, because it's only there that you have access to the databases and the relationships within your systems that you can make that decision. So like there's a whole bunch of things chained together which can impact on how to mitigate these problems.
Absolutely. I think that's why even thinking from our end, because like you said, we are working in the API management sector, so to speak. And it's a lot of times people think about, you know, you're bringing in something like an API management platform or API gateway, and that's going to auto-magically essentially make your system or solution secure. And that's typically not the case. I mean, it can definitely enhance your security. It does a lot of the things that you might want with, you know, authorization, rate limiting. Some of those things do come out of the box. For us, we've got a lot of different plugins that are associated with it, which can help you address some of those things. But by no means is it going to be exhaustive ever. You need to be able to have that full view of your entire stack and consider what is the right tool within your stack to actually address those problems. Like you say, you need to have that, you know, the BOLA example, for instance, you go all the way back to the server, you manage that at the API level. You could potentially work around that at the gateway level, but that's not the right tool for it. And equally, if you think about exactly right. So equally, if you think about something like, you know, identity providers, for instance, when you think about, you know, how you're going to be looking at dynamic client registration, identity providers potentially could help you out with that in a lot better way, or maybe the best way to go ahead with it, with again, an API gateway playing a different role, almost like a mediator between your overall stack versus trying to take all of that on itself. So there are different components. So definitely when you're thinking about API security, think about your entire stack. The weakest link in that API stack is going to determine how secure your stack is. So definitely think about each component and how secure they are, and what is the best use, or which is the best tool to actually address the right problems. Don't think about one single solution that is going to be doing everything for you. There is no such solution. It has not been invented. If you do invent that, you would probably be a billionaire at some point, but in most cases, it is going to be fake, because ultimately your tech stack is complex. It is not a single thing. Therefore, you need to consider all of the different areas of it. So with that in mind, I think there are a couple more questions when we think about API security. Or planning out API security. And by the way, people in the audience, I see a few people over here, so please feel free to send us your question while we are having this discussion. We enjoy this topic so much, we might keep going, but definitely send us your questions. There is a Q&A section at the bottom of the screen. There is a chat section at the bottom of your screen. You can raise your hand and I'll come to you. So any of those options, do feel free to tell us, and we will pick up your questions as we discuss this. So with that, let's continue. When we talk about API strategy, obviously there is always this thing, and we've been asked about this quite a few times, where which is better? Do you build out an API security solution yourself in-house because you feel like your needs are custom and it requires specific attention? Or do you go for an off-the-shelf product? Do you go for something that is a solution that's out there already? Maybe it addresses some of your problems, maybe you build on top of it. So what do you think, Stefania, this question's for you to begin with, in terms of custom in-house solutions versus off-the-shelf products?
Sure. So I get asked this a lot, not just about API security, but about security in general. And what I'd say, so this is for the security like umbrella, unless you work at a security product company, I wouldn't go in-house, because you don't want to reinvent the wheel. For example, you're like, oh no, it's fine, I'll do my own encryption algorithm. Really? The thing is, what you actually want to do is use a tool, that you can get externally, and then provide your logic on top. So for example, the lack of resource and rate limiting, you will know at what level that needs to be. Maybe you keep the payload size a certain size, or maybe you have one team and they need a lot of payload, but they only need it once a month. So if they want a lot of payload every day, then that's a problem. Either you need to send the internal memo or block them or whatever it may be. But I wouldn't recommend taking everything in-house, because then it's like having a product. So you then have to be responsible for keeping it updated, keeping all the libraries updated, doing your own documentation, having the upgrades, listening to customer feedback, improving. And that in itself is, like I said, unless you work at a security product company, for example, I work at Gitlab, we use Gitlab. So we use it for our DevOps and we use it for our security, because that's what we focus on. But if we were doing something like, IDP, we use someone else for that. So it can be very tempting to go fully in-house, but like I'd say, what I do is speak to the experts. For example, Gartner and Forrester can be good to point you in the right direction. Who are the best in the field, who are the known names, and then speak to those organizations and find out if they can help you with your, custom business logic to satisfy your use cases.
I would absolutely concur with that. David, yeah, sorry.
Me too.
If you were to add something.
Well, yeah, for me, it's like it's the same thing really, but look at the cost. What's the cost of building and maintaining the software versus licensing it? That's the point. You made that point already. And do you have the relevant domain experience in those technologies? That's also what you said. So I think you already read my notes on this one, so I don't have much more to add. But
I think having been there, done that on this bit, especially when it comes to API gateways ourselves, because we get asked this question a lot of times. Oh, yeah, we can build our gateway ourselves. Like, that's like a common thing. I don't know whether that's meant to be like a sales tactic or not, but like, yeah, we can do this ourselves. Why not? Like, yeah, sure, go ahead. We'll talk to you in 12 months and then we'll see how your business is doing, because, that's not core part of what you do. And the whole idea is that, you've got solutions out there. Make use of it, make your life easy. Like you said, make the right path the easiest one, right? So the ultimate idea there is, your business needs your focus more than having to build secondary tools that is really going to be, at this point, might seem like it's going to be cheaper, but in the long run, it's going to, like you said, the upkeep, the maintenance, the domain expertise, people might leave your company, you might have to hire people specifically for this. So there's a whole range of upkeep costs that I think a lot of people don't think about upfront when they are considering building the wheel themselves. So I feel like we are in this room, we are in agreement that definitely go off the shelf where possible. And perhaps even if, say, your requirements, not all of them are met off the shelf straight away, perhaps pick a solution that is flexible enough that you might be able to build on top of, instead of doing everything yourself. Even if you're covered maybe 50%, maybe build on top of that, or maybe if you get a little bit better, then that's fine. So I think that's where flexibility of solutions, flexibility of technology is quite important as a strategy. As an organization, you need to understand that the security landscape is always evolving. There are new threats that are being discovered. OWASP, like you said, OWASP Top 10 is going to be updated again for this year, as it's going to be next year and the year after that. So every year there's going to be something new. So the idea there is going to be that you need to understand your stack well enough to know which are the flexible components and how you can make sure that when a new security threat is coming in, you are at least to a certain degree prepared for that, to be able to address that, as opposed to having to completely revamp a big part of your technology stack because of a particular security threat. So flexibility in mind, I think, goes a long way when it comes to API security as well. So keeping that in mind, maybe another
I'll just
question.
add one more thing, if that's
sorry,
okay. It's only brief, but I'd say also that organizations which, say, have multiple teams or run some sort of microservice architecture with lots of different squads and so on, they could actually benefit even more, because you're able to then benefit from that off-the-shelf software across several different squads or teams. Whereas if they were all left to their own devices, would they all implement their own thing? And how would they all talk together? So by sort of adopting it across a whole organization, especially a complex one, I think there's potentially more value to be had. So it's just something to bear in mind as well.
Absolutely.
Also, so one other point I was thinking, but when you were talking, is about find someone who can satisfy most of your, use cases. And then what I'd say, I've worked in a lot of product organizations, product owners in general, they quite like speaking to their customers because they're like, oh, you're in the financial services, and this thing is really important and would make you really happy. Well, if we do that, actually, that'll probably make our other financial services happy. So a lot of the time, especially with technology companies, product owners actually want to hear what you want to use the product for, because it helps, it helps us make our product better. So don't be afraid, if you are having those conversations, to suggest new features, because they might end up in the roadmap to everyone's benefit.
Absolutely. I think if organizations are not keeping an ear and eye on the ground, I think they are missing out. They're missing out on being relevant a few years down the line, I feel. So absolutely, feedback loops, very, very important. An interesting point that Amit makes in the comments is around how a lot of tool selection today and technology selection can also be very CV driven, where you're really trying to pad that CV with, having that added skill set for, for a specific domain, as opposed to actually thinking about what is the real requirement of your organization. So CV driven development, not really the best strategy when you're thinking about API security or anything in general, usually, unless that's kind of, or rather not. I would retract that. I would say definitely for API security, but in some cases, if you're going for innovation, maybe it's worth looking at new technology and trialing it out, and maybe that's solving a specific problem that can then be adopted further down the road. But your intention ideally should not be padding up your CV, if at all. If it is a consequence of that, then that's fantastic, but probably not the best way to go about it. So thank you so much for that comment, Ahmed. Moving along on the point of API strategy, I think we've seen organizations today. So obviously evolution of APIs that's gone through a few changes already over a period of time. We started off, I don't want to go all the way back perhaps, but I think we'll go back enough to go to SOAP first, and then coming over from SOAP onto REST, which is the most popular API style at the moment, to GraphQL, to gRPC, and potentially whatever is going to come in the future. So we've seen that evolution happening, and organizations today are still using a subset of, combination of some of these things. So question to you, David, in terms of, addressing API security, especially maybe in the context of OWASP top 10, does it vary depending on different API styles, or is it something more general purpose that's coming up with, the 10 things that we just discussed?
Well, if you read the top 10, you'll note that they don't really mention any particular style as such in their descriptions. So the threats are quite generic, actually, across the board. Most of these things, it doesn't really matter. Take the first one, BOLA. Does it matter whether it's a SOAP or a GraphQL request that lets you access the data you're not meant to access? It doesn't really matter, does it? So they can all be exploited in some way. It all depends on how the backend's been written. So in general, the issues are generic, but I'd say that each of the different protocols and technologies can either help or hinder the fight against these threats. So and also I'd say that because one of the criteria in the top 10 is prevalence, so one of the sort of ranking criteria in OWASP is prevalence. So I'd say that if you're dealing with a rather niche technology, then it's really like, if it has a particular issue, it's very unlikely that you'll see that in the OWASP top 10, because it's just not going to be prevalent enough. But having said that, the ones we did mention there are all quite relevant. So with SOAP, for example, you could say, because that's an XML-based protocol, so that could be subject to external entity injection, which is actually on the standard OWASP list, top 10, but it isn't in the API one. But what happens there is if you can inject these objects into the payload and they can be executed on the server side. So just like any other sort of injection style attack, right? You're putting something in the payload and it's executing on the server and causing a problem. So that's something that could affect a SOAP API, for example. With GraphQL, then that one can fall foul of complexity. So because you're able to construct your queries and have circular references between objects, you could construct a query where you're just going back and forth between the same type and then causing a whole bunch of load on the server. So that's typically fixed by putting some limitation on the depth of the query there. And then with gRPC, well, these ones aren't so much of a, well, I couldn't find so much information actually about OWASP in relation to gRPC. So I guess they're not all that vulnerable. But typically gRPC is used in sort of service to service or like microservice type architectures where efficiency is needed, where there isn't really a human having to construct some sort of query to send over to it. So the concerns there would be probably the typical API concerns around secure transmissions, proper authentication and authorization. But one thing to note about them, I'd say, is because they are the data is not sort of human readable, it's hard to do logging and monitoring of them in such a way that you're able to sort of retrospectively say, look at these things, because the payloads may not be so readable as they would be with, say, plain text or stuff where you have a request coming in and with TLS and then it's being decrypted, and then you can make the logging on it on the server side. So with the gateway, it would probably just pass through without really understanding what was in it, which makes it's harder to do that sort of retrospective analysis. So
right, yeah.
So yeah, to summarize, I'd say it's pretty generic, but there are a few things with each technology which can cause problems, but it shouldn't be too hard to figure out what those things are.
True, I think, but I would almost caution folks as well, because I think a lot of times I see a challenge that comes across with API security is that you're trying to use whatever you've used with something like REST and try to just apply the same directly to something like gRPC or GraphQL. And like you say, for the most part, you still have to follow the same API security practices, but there are nuances associated with them where, you know, they do operate a little bit differently, and therefore you need to be aware of those different nuances to make sure that you're not leaking data, you're not exposing data in a way which is, you know, which is going to be risky for your business. Same with gRPC as well. Like I would agree, I think it's not as human readable as REST and GraphQL, but at the same time, you are talking about streaming between different services, and potentially when you have those streams, you might want to consider how long you want to keep that communication channel open. There might be, you know, a time that you want to fix there. You don't want that to live forever, because then, you know, you're opening up a connection which while encrypted, again, if it's gotten into wrong hands, then, you know, it could be a problem there even with streaming. So just a couple of things to keep in mind, because while I completely agree, the OWASP top 10 are more general purpose in nature. They talk about security generally. I've seen a lot of standards tend to focus too heavily on things which are associated with REST, and I see that with compliance requirements as well. But with the world evolving into something where GraphQL is starting to pick up in its acceptance, where gRPC is being utilized a little bit more, I think I would recommend folks to understand the technology that you're using more and identify the issues that are specific to that technology, as well as what is being mentioned in a general purpose way as well. So you mentioned GraphQL, depth limiting, field-based permissions, all of those different things are quite important, because again, the way GraphQL operates, exposing information in a more flexible manner, that could cause some issues when it comes to, you know, you're giving that power to the clients to request specific information. And again, if you're not understanding where that request is coming from and how that's coming in, you're going to be in trouble. So just to keep that in mind, I see a hand has been raised here.
I'll just add in, if I can, before that, I'll just say that OWASP do provide, alongside the top 10, a whole load of cheat sheets that cover loads of these things. So they're just a lot more focused on things like, say, that XXE thing for SOAP and XML. Yep. So they provide little cheat sheets for that. So you can go and find it on the website.
Perfect. Thank you so much. Paulo, I see you've got your hand raised, so I'm going to enable you to talk. So if you want to unmute yourself, please tell us what your question is.
Hi, everyone. It's a pleasure to be here. I saw David mention injection. lots of people are not aware that you can have second level or second tier injections. So basically, it's saved in your database, and when you are reading from the database, it will be executed on that time. Or when it's persisted to the logs, it will be happen afterwards, or when it's loaded not in the case of an API, but with a web API. So it's not always direct first tier or first level access injections that gives you the results straight away. It can be later when executed. Also, Budha, you mentioned that when you don't know where the request is coming from, I think one of the first things that any developer should learn is the difference between who and what is making the request to the API. And in my Stack Overflow answers about security, I always mention that, because I know that lots of developers, even the most experienced ones, are not aware of that difference. So who is in the request is the user that the request is representing. So you have authenticated with OWASP or whatever other mechanism. That is the who in the request. What is the request being made by a bot, by the genuine mobile app, by the genuine web app, by Postman, by you, David, walking around manually with curl? So the developer needs to understand the difference between what and who is in the request. So if you save that in your mind, then you will see API or web security, application security with a different mindset, and you can see other threats to your code that while you are writing it. And also, please do security by opt-in, not opt-out, as everyone continues to do in our industry. It's staggering that after so many breaches, new software development still continue to be developed with security as you need to security not opt-in, security as opt-out. Sorry, I made a mistake.
Yeah, the flip side, right? Because you're essentially, you're secure by default, or at least try and be as secure as by default, and consider everything as a threat. Essentially, you're going with that's what the entire paradigm of zero trust, I think, comes in, where you're really thinking about everything as a potential threat, and then you're trying to open things up to the world a little bit more.
So basically, developers need to learn to unsecure their applications instead of needing to learn how to secure them. I was not understanding nothing on security, but when I started as developer, one of the first things that I used was the LAMP stack, and I was surprised that MySQL was open, and I needed to learn how to secure it. What the heck? This doesn't make any sense. And I was not even yet keen on security, and just bluffed me.
The thing that caught me off guard sometimes earlier on, because I think when you start off with your programming journey, a lot of times you end up writing vanilla code, which means that, if you're starting with Python or PHP, if you're writing web application, a lot of times you try to do that on your own. You're trying to address some of those issues on your own. Whereas, what ideally you get started off with, there are frameworks out there, and I'm not saying they're again secure by default, but they provide these libraries and mechanisms that address some of those issues out of the box almost. So you essentially use those to make sure that you're addressing some of these basic things, and of course, build out your logic on top of it, get your gateways in place, get your different components in place as well. So one of those common mistakes that I have made myself, because I started my journey with PHP, as much maligned as it is in today's world. With PHP, I think with some of those issues came up quite quickly, and I was like, oh no, I think a framework would really be beneficial there, especially dealing with databases. And injection was probably the first security threat that I had to address there. So absolutely agree with you, Paulo. Thank you so much for that.
Unfortunately, it's not only on PHP and Python, it's across all language,
across all of them, absolutely.
Ecosystem. Okay, absolutely. Thank you very much.
Thank you so much. Thank you so much.
Yeah, thanks, Paulo.
Okay, yeah. So thoughts on that. So we are coming almost to the end of it, but absolutely right. So this is kind of the trend that we've been seeing, where I think security is no longer or at least we are hoping that security will no longer be an afterthought, where, you know, the entire trend of shifting left on API security has come up in a big way, especially in DevOps, or I think the extension of that DevSecOps is a big area where you're not thinking right at the end to you know, make things secure. You're not, that's not the part of the paradigm. You're thinking about it baked into your overall solution in your process. So maybe Stefania, I think you feel like, I feel like you might be the best person to ask about this. Shifting left on API security, your thoughts on that?
Sure. So I think a lot of the time when people think about security, maybe they're thinking, you know, of a web app, of a mobile app, and then you came to, you know, infrastructure as code, and it's like, okay, so we're provisioning these environments using a Terraform script, but are we doing static code analysis on that script? Like, are we checking that we haven't got any credentials stored in plain text just in our, you know, .tf? And I think you can apply those, just how we started to apply it to infrastructure as code. I think it's so important with API testing. So, for example, are you scanning whoever is creating the APIs? Are you doing security testing as part of that? You know, are you doing threat modeling? We've talked a lot about authentication. You know, are you checking who can do what and how? And then applying the same principles that we've, you know, learned and benefited from with DevSecOps and with DevOps, and kind of, you know, shifting left and, you know, doing small iterations. Using that with API, because it's the same thing. You're creating an API. It's a process. So making sure that that is created securely, and then similarly going from the very shift left, also on the right hand side, are you monitoring? So are you seeing what these APIs are doing, what versions are out in the wild, which is most popular, why it's most popular, where is that traffic coming from? Is it from you know, I say good sources, but is it from nefarious sources? So especially, you know, when we think security, it comes back to my point about making the easiest path, the correct path. So I think sometimes it can just be a case of, I think that's where the initial investment needs to be. It's like, how can we make security as easy as possible? How can we get it into the developer workflows? Because I think, yeah, the first step is creating these APIs securely, and then maintaining them and monitoring them as well. And I think there's a lot of lessons from the other you know, IT teams which we can then apply to API security.
Definitely.
Okay, fantastic.
Yeah. And if you can afford it, do some external pen testing, because I think you might be blind to your own mistakes. And if you have someone from outside look at it, then you can at least hopefully be a bit more assured that what you've done is correct. Yeah, especially if it's not your specialism.
It's like that joke. It's like a QA engineer walks into a bar, orders 1 beer, orders -1 beer, orders ACDJ beers, orders a lizard. A real customer goes in, asks to go to the bathroom, and the bar bursts into flames. So yeah, to David's point, you know, having an external security expert can really turn your app upside down and find any potential weak links.
Definitely. And I think that's something that, again, you should be doing on a more ongoing basis. It's not one and done when it comes to security, because the security is not one and done. Your solution is not one and done. You're going to be evolving your solution. You're going to be therefore needing to evolve your security requirements, and therefore your testing needs to evolve accordingly as well. So absolutely not a one and done ever when it comes to technology, when it comes to security as well. So keep that in mind as well as a key takeaway from this too. I think we're almost at time. We've got the last 5 minutes. Maybe the best way to end this is perhaps one do, one don't when it comes to API security for organizations today. Individuals, organizations, I think we will keep it a little bit open more, but one do, one don't when it comes to API security. Maybe we'll start off with you, Stefania.
Sure, I did my gut reaction, which is the do. It's like, do API security. So that's the kind of do, the top level. You know, we talked about it a lot. You know, start with the OWASP top 10. That's a great foundation. Don't necessarily believe you can do it yourself unless you work at a security tool. And then you can also speak to other people in industry, see, you know, who's doing interesting things, who can satisfy your use case. And don't leave it too late. APIs are very powerful. It's a big attack vector. So don't think, we just need this API. It's okay. No one's ever going to use it. And then 6 months later, it goes from private to public. And all of a sudden, So yeah, do it, and then starting with OWASP top 10, and don't leave it too late.
Perfect. Over to you, David.
Yeah, so it's bad going second on this because I sort of know I used your example, but I would say do explore and this is on the topic of like off-the-shelf software types of things. Do explore what's out there to help solve the problems quickly without having to invest too many resources yourself in it if you can. So that's the do. And on the don't, I would say, and this is like a double negative, but don't underinvest in supporting teams in achieving the aims of like OWASP and all that. So don't just expect that they're able to handle security issues if it's not being built into the project processes that the APIs are being built with. There needs to be adequate time put into running API programs such that the teams who are delivering them have the right level of knowledge and have the enough resources and time to be able to implement them correctly. So it's a double negative. It's like two do's, but there you go. You put me on the spot, so
no worries. I'll give you my do and don't. I think my do would have also been have an API strategy. Given the stats, it's a bit staggering in my head. But if I have to pick one, I would say document everything, whether that is documenting your code, whether it's documenting your processes. I think oftentimes we have this issue of just having things in people's heads, and then those heads go away and we are in trouble. So I think document processes, definitely document. I think documenting process also has an added benefit of getting buy-in a lot easier, as opposed to, a person being responsible for it, because that document can then be reviewed. People could add on to that. It could be a working document that is built collaboratively as opposed to built from an individual perspective. So your strategy overall needs to have that buy-in, needs to have people aware that what they are doing on a regular basis is having an impact for the better or for the worse in some cases. So therefore they need to take that responsibility. Responsibility of securing your application is not just for a single individual developer. It is pretty much everyone who's involved in that product has a part to play there. So absolutely do document everything, document code as well as document processes. I would say don't consider silver bullet solutions. So don't think of a single solution that is going to save you in some way. There are no superheroes here. Specifically, we are really looking at a collaborative technology team effort where every single component of your stack is contributing to the overall security of your application. So you need to be aware of that. You need to identify which tool is best for which job, which role, and bring them all together harmoniously, perhaps cohesively, perhaps maybe with an API management platform, or maybe with anything else that sort of holds it all together to build that product. So no silver bullets, and definitely consider documenting things as you go along. So with that, I would say thank you so much, everyone. We are exactly on the dot with 1 minute to go. So thank you so much. This has been a fantastic conversation. Thank you, everyone in the audience as well. And a big thank you to Stefania and David.
Awesome. Thank you so much for having us. Thank you, Budha.
Yeah.
Incredible. All right. So until next time, folks, take care. And we will be sending out the recording of this right after. So see you next time. Bye-bye. Take care.
Bye.